I've been throwing around this theory that we're going to end up with a world of superheroes and supervillains. Um, do you see that as an actual reality?
Unfortunately, yes.
Anyway, so my guest today grew up in India building Lego crane sets. He taught himself how to code on his father's PC and moved to the United States to study computer engineering, where his senior project, a chess-playing robot, won best in class. That curiosity never stopped. He spent 16 years at iRobot, first helping deploy the over 1,000 bomb disposal robots in Iraq and Afghanistan, then leading a 60-person team to build the company's first robotic lawnmower. After iRobot, he went on to lead multiple robotics startups as a CEO and president, scaling autonomous mowing companies and building a consulting practice that's helped hardware companies get to market faster. Today, he's the CEO of RISE Robotics, a Boston-based company on a mission to replace every hydraulic actuator on Earth. Their patented Beltdraulic technology, inspired by how human muscles actually work, is 3 times faster than hydraulics, 3 times more durable, and uses zero fluid. In 2025, the robotic arm set a Guinness World Record by lifting over 7,000 pounds without a single drop of hydraulic fluid. They've raised over $7 million from more than 2,800 investors, been named the #1 crowdsourcing campaign in the United States in 2025, and holds an active contract with the US Air Force and the US Army. Oh, and when he's not electrifying heavy machinery, he's behind a drum kit. He grew up playing tabla, and he hasn't stopped playing since. Please welcome to the show the CEO of RISE Robotics. Um, so before we get anywhere, I ask all of my guests this one question: what's a truth in your industry that people do not want to admit?
Cody, thank you for having me on the podcast, and thank you for that amazing introduction. I think one of the truths that folks don't want to admit is that humanoid robots are going to take a long time to come to market, and that the hype is ahead of where the practical reality of that product is. Eventually, ubiquitous, but for now, I still think humanoid robots are in the home are at least 10 to 20 years away.
That's really sad for me because I'm really looking forward to having a robot cook my food. Um, so why do you say that as opposed to what Elon Musk is saying? And he says, if I'm not mistaken, it's like within the next 2 to 3 years, like 1 billion robots in around the world.
Well, a lot of founders often will hype how soon they can get something to market so that they can get the investors behind them that they need to make that vision a reality. So it's important to articulate that things are going to happen sooner than they actually will. If you just look at the timeline for the Tesla Semi and try to extrapolate that and use that as a multiplication factor, I think you can get to a realistic estimate of when um, is it the Omnibot or yeah,
Can't
when
even
the
remember.
Tesla robots will be in market. Um, yeah, so I think it's important to have that vision and craft that vision and to be aggressive about that vision because you do want to push your teams to really think about timelines aggressively. I've had to do that in a lot of programs myself. When I was running the lawnmower program at iRobot, I often had very aggressive deadlines because it's not that you want the team to kill themselves, but you want to actually create some conflict around the scope. You want the teams to come back and say, hey, you're asking for too much in this time frame. Here's some things you need to give up. Because everyone in an organization wants to add more features. There are very few people inside a company that are saying, let's do less, right? The folks that are, even the voice of the customer people are usually saying, hey, we need this feature, that feature. Here are the 3 things the customer would really like. The engineering team loves to solve problems. And so if they find problems, they're like, let's go solve that problem. Often it's the folks that are, tasked with revenue goals and tasked with time to market. Those are the folks that are usually pushing back and saying, let's try to do less. And that's important. And that conflict only happens when you have aggressive timelines because things will always take longer than you think that they will.
That kind of speaks to a topic that I came into when I was reading up about you, how you've kind of leveraged your lean methodologies to focus on that. How has that benefited you in your past?
Yeah, usually, folks are working as hard as possible, assuming that you have the right team and the right culture, and you really if you want to go faster, you have to find ways to do less. If you pile on more things, then what ends up happening is you might still end up with something that looks like it has all the features, but then you compromise on testing, or you compromise on the cost, or you compromised on the overall user experience because you haven't really dialed down everything perfectly. So you might think that the system has all the features in it, but then you try to use it and then you realize, oh, it's got some shortcomings. And one of the things that I think
The
Apple has done really well is they've really eliminated as many things as they can and still tried to make a fantastic experience. Right? So first they started with eliminating the keyboard. And as a side effect of that, you got a much larger screen. The next thing they did is they stopped chasing specs. And so they've settled on, 330 pixels per inch as the resolution that they want to sell the phones at. And that has allowed them to keep the processing low. It's allowed them to keep the battery size low. And so they're selling a premium phone at a competitive price to a lot of other companies that are trying to chase specs and adding features that customers don't want. So they've done a really good job of keeping, on the hardware side, things very simplified. And for example, when there was a mandate by the EU to go to USB-C, right, one of the decisions they made was to drop the fingerprint detection or the fingerprint identification unit there, because to add that and the USB meant that the system gets more complicated. So they've been cutting scope. And in some ways, Face ID, even though it seems like a more sophisticated feature, is easier to implement in hardware than the fingerprint sensor, right? So they're constantly cutting scope, making the product better. And I'm kind of inspired by that, trying to find ways to do less at a higher quality, which really gets the customer excited, as opposed to tossing in features that don't work.
that's fair. The whole three type matrix. You can either have it fast, cheap, or good, or fast, cheap, or quality. What do you try and prioritize?
Well, when I joined RISE, one of the things we put in place is a set of values. So the 5 values for RISE Robotics are safety, that being number one, because we work with very large things. So we want the product to be safe for our customers. We want the work environment physically to be safe for customers, for our employees. And we also want the space psychologically safe for employees so that they can raise issues and concerns and we can address them. So safety is our number one value. Then the next thing we prioritize is customer focus. So, early on when I joined, one of the teams, a couple of the team members asked me, hey, do you think we should be creating drawings in metric or in imperial units? And my answer was, well, what does the customer want? If it's a Department of Defense customer and they want imperial units, then that's what we're going to deliver. And if it's a European customer and they want the drawings in centimeters, then that's what we're going to give to them. And, it's not a great answer for the team that wants a decision on let's do it one way. But if your customers are pulling you in different directions, then you have to find a way to meet the customer needs. So that's number two. Our third value is being collaborative. And so collaborative involves constructive conflict. It involves people being assertive about what they see, but it also involves people being responsible for having good relationships with their coworkers and finding a path forward that works for everybody. It takes a little longer than compromise, or it takes a little longer than just avoiding the conflict and saying, I don't care, I don't want to speak up. But I'm encouraging teams to engage in healthy conflict, which is something I've had to do at every team, because I also don't like getting into conflict, and nobody finds that enjoyable. But getting to good outcomes means that folks have to talk through what they see, and if they see different things, how to reconcile them and get to a common path forward that everyone can get behind. Our other two values are continuous improvement. So we want to continue to evolve as an organization, and things that we did, last year are not things that we want to do this year. In fact, since I've joined, one of the things that we've focused on heavily is to cut down on the number of meetings. And when I joined, we had probably 50 total man hours worth of meetings a week, different people talking together about different things. And now we're down to one 15-minute tag up a day by the team, an hour and a half meeting of the leadership team once a week to make sure we're all aligned and surface any issues, and then a 1 hour prioritization meeting. So we're down to a very lean set of meetings, and we're continuing to improve how we run them. And then the last part is to find ways to be energizing. So we have a once a month team building activity, and we also try to find ways to talk to the team and say, what gets you more energized to be at work? Because if they're more energized, then they'll work harder and they'll be engaged in their work, and then we'll get more output without asking people to spend more time necessarily in the office.
That's very fair, and echo that sentiment as well, because I used to work in government, and it was like, I'm a software engineer by trade. Government was, I spent more time in meetings than actually coding. And when I took on the entrepreneurial role, it was very eye opening to the amount of work I can actually get done because I'm excited to do things, as opposed to how I was dreading every day going into the office because of all those meetings. How, do you see company culture shifting more towards that now, as opposed to these central conglomerate style organizations?
Well, I guess I have two thoughts on that. One is that one of the interesting development patterns that's come out of software and that's going, across all disciplines now is the agile process. And one of the key tenets of the agile process is self-organizing teams. So how can you get teams to organize themselves around a problem, figure out trade-offs, and solve them? And to do that, you need all the right skills in a team, but you also need to give the team the permission to fail, right? That's the other aspect of it, which when you talk about being in a bureaucracy where you have to have many meetings, it's everyone's too concerned about making a mistake, right? And when you think about all of defense acquisition, and one of the reasons why defense acquisition is very expensive in the United States is that the structure has been set up so that no one can make a mistake. And that is expensive. And you get to some point where the cost of preventing mistakes is more than the cost of making a mistake and learning and getting better. And so creating a setup where teams can make mistakes within a certain healthy amount, right? Within certain bounds, can actually make teams go faster. Sometimes you have you get to a fork in the road where you're like, I don't know if we should go left or right in this particular design trade-off. And you could spend months analyzing which is the right path. Or you could say, it's a 50-50. Let's just pick one, go down the path a little bit, and we'll learn all the things we didn't know. And we'll quickly figure out if this path is the wrong path. And if we can figure that out quickly, then we can flip and go to the other path, and we lost, maybe a week, as opposed to spending a month in debates and trying to figure out what the right path is without doing the work and getting the data and the learning. So I think in some ways, bureaucracies in trying to prevent mistakes end up being organizations that can't learn and can't evolve. So yes, I do see that corporate culture is definitely moving more towards, and has continued to move more towards, enabling folks to take chances and make mistakes. And I think that's happening even more so with these AI tools, which allow people to go faster and try things before they commit to something. So sometimes when I have to write a paper or an article or an email to a customer, I'll run it through, especially if the email is really long, and I look at it, I'm like, I don't want to waste this much of the customer's time reading what I have to say. I'll run it through one of the AI tools and say, can you please condense this? And then I'll look at what the condensed email is, and then say, okay, lost a couple of key points. So I'll put them back in, but now a shorter email that I'm sending my customers. Then, and I can test that, with the AI tool. And if the AI tool comes back as something that's not right, I can just continue down my one path. But so these tools are making it possible for folks to move a little faster, make mistakes faster, correct faster, which I think is healthy.
I appreciate that you try and condense your emails down, because that's the first thing I do when I get a giant of text in my email is I immediately throw it to AI and just say, explain this to me in simple terms, because I think people are done. Well, I think our brains are fried because of social media attention span, to the point where nobody really wants to read much unless it's like something that's enjoyable. And while I'm okay with the making it easier to read, sometimes you lose out on context, but it is nice to have the option now, as opposed to government emails where just walls of text, and that's like, you have to remember everything, and it's like, no, I don't understand half of this. But I do want to get into more of your robotics company. How
Sure.
did you go from an Iron Man exoskeleton to working in hydraulics?
Yeah, so the founders of the company were inspired to build this Iron Man kind of an exosuit. They thought that there'd be applications in helping the elderly sort of continue to extend their independence. And There were applications in warehouse automation or just warehouses where folks had to lift heavy things. And also for defense, people think about these large, mechs that could walk around with soldiers in them, that could go out and do impossible things. So they had this vision to build this. And in that process, they realized that the state-of-the-art hydraulics wasn't going to cut it.
If you're a podcaster or a video creator, this is the all-in-one AI video editor you've been looking for. I've been using Async since day one, and it's amazing to watch it progress into a complete powerhouse for creators. Especially for people like me who, well, can't edit for shit. Async leverages AI to give you total control over your video. You can record, edit, generate clips, add subtitles, and even dub your content in over 15 languages. Plus, it lets you upscale your footage and easily repurpose your content for different platforms, all without ever having to switch between different tools. It's truly a game changer. So if you want to streamline your workflow and make your editing process painless, check out async.com today. The link is in the description below.
They couldn't build systems that could move fast enough. They couldn't build systems that were compact, that were quiet, right? So hydraulic systems waste a lot of energy. So you end up requiring pumps and reservoirs and radiators. And so there's just a substantial amount of complexity around the system. So they looked to nature for inspiration. And then they decided that instead of trying to push fluids around, which creates a lot of stress and is inefficient and is slow, that they would try to do something more electromechanical. And our muscles don't do any pushing, they only do pulling. And so they inverted the architecture and we ended up creating cylinders that do pulling. And we call this technology Beltdraulic because we pull using belts. And these belts are very contemporary. They've been used by the elevator industry for, call it, less than 20 years. They're relatively recent, which is why no one else has done anything like it. And so the founding team figured out, okay, let's do that. And then we came up with this new tech, and it's 3 times as fast as hydraulics. It's 3 times as efficient, and it's 3 times as durable. And once they came up with it, and entirely digital, unlike hydraulic systems, which are fairly analog. And once they built this, they said, you know what? Rather than try to build an exosuit market, which doesn't exist, let's go tackle and disrupt the existing market, because the problems we've solved are problems that folks deal with in the hydraulic space all the time. They'd love to get more productivity. In fact, if you look at all the hydraulic systems that are out there, about $600 billion of productivity is left on the table every year because the systems can't go any faster. And then there are the challenges that folks deal with as folks are trying to get to more sustainable solutions and also trying to reduce their operating expenses. Energy efficiency is one of the things that's key, especially with the cost of electricity going up. And now, fuel costs are up. So folks are definitely looking at ways to get more efficient there. And then there are all these compliance costs that come from leaking of hydraulic fluid, right? And finally, hydraulics, because there's inherently in the system, the physics of the system creates pressure across every single interface and every single wall. You ultimately are going to have leaks. There's no way to avoid them. And so our system is more durable because it doesn't start off with forces being applied to places where we don't need forces to be applied to. We're very intentional about how we move energy in our system. So that's how they ended up with this solution. And we've had a lot of interest from folks that are using hydraulics that would like to do something better, but nothing better has existed till we came up with our tech.
Well, just looking at it in terms of, so this is something I throw around a lot on X, but I talk about a lot about how we need oil in order to build out our green future that we want. And you solved one of the points that I kept on making is you can't build it without using oil. You can't build the green energy without using oil because our industrial machines themselves are entirely oil-based. And I also like that you guys went into electrification. Can you tell me a little bit about how your electric system works as opposed to an oil system?
Yeah. So what we do is in a hydraulic oil-based system, you're using oil to push the piston, right? So you want to create linear movement. You have a pump that creates oil pressure, and then you put it on one side of the piston, and then that pushes the actuator out, and then you put the oil on the other side of and then you pull the actuator in. So you're using fluid to push, right? And every interface, as I mentioned, the hoses experience pressure. Eventually, they're going to burst if you don't do preventive maintenance on them. The valves are going to fail. Every interface is going to end up leaking. The seals have to get replaced because you're constantly applying pressure And what we've done is instead of putting pressure on the piston, we've basically put a block and tackle system on the piston, and we end up pulling the piston in both directions. And in doing so, really, there's no fluid, there's nothing to leak. And the forces are very targeted and targeted just to the piston. Whereas with hydraulic oil, the forces are everywhere, right? The force gets dissipated everywhere. It just so happens the piston is the only part that's designed to move, so it moves. In our case, we only move the part that intended to move.
That's very fair. And just a genius solution, by the way. I'm so excited for what you have in the future. And you're electrifying your machines as well. Can you talk a little bit more about that?
Yeah, if you take so just to take a step back, if you try to electrify, call it excavator today, your total cost of ownership goes up. Because even though you might take the operating expenses down by a third, your CapEx increases by threefold. And that's because the batteries are very expensive and the motors are expensive to put on these systems. And then, of course, you need the charging infrastructure, which is also very expensive. When you use our technology, our systems are 3 times as efficient as hydraulics. So at the system level, because not all the power is going into the hydraulic system, some of it is going to drive wheels. At the system level of an excavator, we end up needing half the total energy. So the battery size can be half, or if you decide you want to use the same fleet over 2 shifts because you don't have to charge as often, now you need half as many machines. So on the CapEx side, we make a substantial difference. And then your charging infrastructure can be half the size because we only need half the electricity coming out of that to charge the systems, right? So that's how we cut down on the CapEx. And then on the OpEx side, as I mentioned, we're taking half the electricity, so the OpEx comes down even further. But then all the maintenance costs disappear because we don't have hydraulic-related failures. So that's how we end up with a system that's more effective from a cost perspective. But then our system also moves faster. Now, just because the hydraulic system can move 3 times, just because our Beltdraulic technology can move 3 times as fast, doesn't mean that you'll get 3 times the throughput. Generally, at the system level, you'll get 15% more output, even though some of the actuators are working 3 times as fast. But that 15% more is huge for a company. Most companies would rather have 15% revenue increase than have 15% cost reduction, because the revenue increase will end up with a much better bottom line than just 15% reduction in cost.
Yeah, definitely even just marginal increases now is saving or giving companies a level up.
Absolutely.
With your system, is it also how much maintenance are we talking about when you install, or when you use them over a period of time?
Yeah, so we've done some analysis on 2 of our products. One is our liftgate product, and we've estimated that the maintenance time is going to be a third that of the hydraulic system. So in these systems, you're typically doing an overhaul of the hydraulics every 2 years preventatively, because you might have, if you have a failure, then you're stuck out, in the middle of a route, which is very expensive. And for us, that means that really no service is needed over the life of the product, because once you 3x it, you're at 6 years, and most of those lift gates get replaced in that time frame. We also did a similar analysis for our commercial customer in the oil and gas space. The hydraulic systems that they use require servicing every 3 months, and our analysis shows that we can extend that to roughly 9 months, roughly 3x. And then when you compare, yeah, it's fantastic. And then when you compare our technology to screw type actuators, we can actually last 5 times as long as screw type actuators, because we don't have the same metal on metal wear that those actuators see.
You've really thought this problem through and have built a solid solution. I do want to ask about how you got your funding, because you did crowdsourcing over VC. What was the decision behind that?
Yeah, so after I joined the company, fundraising was one of the sort of key requirements of the job. And the board had basically told me that while they would back the company, if I needed money, they really wanted me to find other sources of funds. And so I spoke to a lot of CVCs and VCs. And at that time, we didn't have a commercial product to sell and offer, but we were working on it. And so the terms that we were going to get, or we were getting, were very poor, and they would have impacted our previous investors. So they would have, their ownerships would have gotten squeezed down because of the terms that the new investors were offering. So I knew a couple of founders that had tried crowd with a fair amount of success. And one of the other things that I knew, and this was from Aaron, one of the co-founders and the previous CEO who brought me on board, he said that we had 1,500 followers on LinkedIn, and many of the suppliers who would come into our facility and our shop to deliver parts and components would see what we were doing and would often ask us, hey, how can I get in on this company? How can I get in on the upside? Because the thing that you're doing is really interesting and new and unique. And so I sort of put two and two together. We're getting not the best of terms from VCs, from financial VCs. And then we had a set of followers that wanted to get into the company. And so we looked around, we found a platform called WeFunder. There are three platforms that they're like three platforms that dominate crowdfunding today. And WeFunder was the top one at the time. And I think still is. And we did a testing the waters campaign. We just said, hey, as a trial, who wants to invest in RISE Robotics? And over a couple of months, we had $800,000 worth of interest. And so we were like, okay, it seems like there's interest. So why don't we open up the campaign? And to our astonishment, we ended up being the #1 regulation crowdfunded campaign of last year. The SEC only allows us to take a 5 million max. And we ended up with $5.8 million of interest. So we had to open another round so that we can capture all of that interest. And surprisingly, we've raised another 2 million, and people continue to find our campaign and continue to invest in the company, which is fantastic. And what we've done with those funds in that time is we finished our commercial offering, and we landed our first 8 commercial customers, and we took our liftgate product through a pilot, and we learned a lot of things, and we've addressed those things, and we're getting ready to do our next pilot. We also landed a $3 million Air Force contract. And also during the same time frame, we won the Guinness World Record for building the world's strongest robotic arm prototype. So a lot of our investors ended up with plaques that said, you helped us win a Guinness World Record. So I'm sure they have them mounted on the wall somewhere because they're excited to make that happen for us. So it's gone really well.
And not only that, you're basically building a community around what you're building as well that people will identify with and resonate with. Even just looking you up, I was like, wow, how can I invest? But I'm in Canada, I can't do that. So I want to get a little bit more into your background. Where did this obsession with robotics come from? Here's something I don't say out loud much. I forget half of what is said in a conversation while I'm still having it. And this is Plod. I backed it back when it was still a Kickstarter. So I've been using this thing since before most people even heard of it. It records all of my meetings, my calls, whatever, and turns it into a clean summary with decisions and action items already pulled out. And it's not just the card. They also have a wristwatch/necklace version that I can wear, clip it, or drop it on a table, hands-free, while I'm still looking at the person instead of my notebooks. The best part? I own the notes, I'm present in the room, and the summary is done before I even leave it. I've been on this since day one for a reason. If your brain leads conversations like mine does, the link's down below. This thing I actually use every day.
Yeah, I think I was a kid in India, and I remember we didn't have a TV, but our neighbors had like a 12-inch black and white TV. I remember playing in the street behind our house, and a bunch of kids were like, "Hey, it's time to go see Johnny Sacco and the Flying Robot." And I was like, "What is that?" Because I, again, didn't have a TV, didn't watch the shows, and so they dragged me. And so there's 15 kids. I think I'm trying to think, maybe 5 years old, and so we're all clustered around, like 15 kids clustered on this small 12-inch TV, black and white TV, watching this show that was Japanese but was dubbed so we could read the English subtitles. And it was about this kid, Johnny Sacco, who had a flying robot. And it was just a kid show. I watched it again, and I just can't imagine that I liked it. You see how those kid shows, they're really exciting at that age, but like, wow, they're taking up 10 minutes just to do the standard animation, and the same 10 minutes are being repeated every show. But yeah, I got inspired then, and I decided I wanted to get into robotics, and that passion has stayed with me since.
So why did you switch into computer engineering?
So I was fortunate that I had family in the United States who would bring me Lego sets. They were unaffordable for my family in India. And so I started playing with Lego sets, and I started to develop an intuition for mechanics. But then I discovered computers at some point and started doing software, and I found that to be interesting as well. But the one thing I was missing in the middle was electronics and how the software would make the mechanical items move. And so when it was time to pick a major, I picked computer engineering because I wanted to build on my software skills, learn more about electronics and how that all worked, and then eventually connect it to robotics. So that's how I ended up picking computer engineering as a major. And then at that time, if I wanted to study computer engineering in India at one of the public universities, which is what we could afford, I would have to take an entrance test and score in the top 50 out of, I think it was 100,000 kids that were taking the exam. I think no, it's more than that. It was like 1 million kids taking the exam, and I had to score within the top 50. And those odds, I couldn't hit those odds, and so I ended up taking the SAT, scoring in the top 1% globally, and then ended up getting a visa to come to the United States to study computer engineering. So that's the story. And then, as you mentioned, I ended up working on my senior project, which was a chess playing robot, and ended up being the best project in computer engineering at my alma mater.
What did you see when you built the chess building robot? What did you see for AI before the rest of us?
That's a good question. So I was inspired by IBM at that point building Deep Blue, which was the chess engine that for the first time beat the reigning human chess champion. I think it was Gary Kasparov at the time. And so I was inspired by that. At that time, this is actually held true, is that we keep redefining AI to be the thing that we can't yet solve, right? So it used to be the case that trying to get computers to play chess was considered to be AI. But over time, the computer science field developed techniques to solve those problems. I think they're called alpha, beta, minimax trees. So you create this tree, and then you use a score to determine which side of the tree you're going to go down on. And then over time, you do a search that allows you to get to a pretty good answer, even though you haven't searched the whole space, but you get to a pretty good answer. And then they started to add, opening books and closing books and those sorts of techniques where you're just feeding a database of information that the computer could look up in areas where search was ineffective. So they sort of, use multiple techniques to solve the problem. And then after that, the search algorithms started getting better. In video games, A-star came out, right, which is a way to find things when you don't understand the problem space. And all of those things then stop being called AI because they're just now techniques we understood. And then for a while, Bayesian filtering was considered to be AI, and then eventually, it just became one more technique. And then deep learning was AI, and now it's just deep learning. It's just a way of doing statistical analysis. And for a while, we think LLMs are AI, but now we understand what they are. Again, they're just a different way of statistically looking at data, pulling it together, and then running it through some modules that filter the information and structure it in a way that humans find useful. So for me, I feel like this trend of AI continues to get redefined as we solve a problem. And now, of course, the holy grail is AGI, which is like, hey, we'll get to generalized intelligence. And I think it's ultimately just going to end up being a bunch of different techniques that are all added together. And, they end up looking intelligent, feeling intelligent, but ultimately it's just algorithms that are stitching the whole thing together.
It's something I'm trying to impart on my audience is these are just fancy automations. They're nothing, there's no intelligence behind it. And actually there's a user who's defined it well in a way that I can say that is like understanding. And all LLMs is a mirror of how you use it. It is basically taking and learning from you how you interact with it to become a predictive engine for the next action you are going to take. I don't even think LLMs are going to be the end solution. I really think SLMs in clusters working in tandem for working on small problems at a time together is actually how you're going to end up with an AGI model. And I don't know if any of the AI companies are doing that, but if they're listening, I feel like that's a very basic solution. But to that extent, what is the problem we haven't solved yet for this instance?
Specifically related to AI or?
Yeah, specifically related to AI.
Yeah, I think so. When I think about LLMs and those sets of problems, I think the things that we're missing right now is it's a black box. So we don't have a sense of the understanding of how confident is the system in the data? Can we trust it, right? There's all this hallucination that's happening. So that's got to be fixed. Second one is that training seems to be very expensive, energy inefficient, requiring a lot of CPUs. So we have to find a way to do that better. So that I think has to get solved because there's a limit to the amount of power we can put into these systems. And that's going to be the constraining element. So if folks can find a way to do it, 10 times as efficient, we can get 10 times further with the same amount of energy. And then the third part is that these things you don't understand when you reach the limits of what the network can do. So you start to get things like catastrophic forgetting, where you've put in the information, but it just lost because there's just no more storage in there. And again, we don't seem to have a handle on how to figure that out. And I think what we need there is a way to understand how saturated the network is getting, and if you need to add more nodes, and how can you add more nodes. So I think those are three problem spaces that I think need to get addressed here in the near term.
That's very fair. I didn't think about the network problem at that point. I try and use as local models as possible, but I know my own systems are constrained. So I notice when my GPU decides to shut down. So where are we at for AI in terms of robotics? Sorry.
Just trying to turn off the dings. And I have to give that question just a minute of thought. Yeah, so I think we're making a fair amount of progress in terms of AI and robotics. One of the breakthroughs recently has been training through sim, right? So you look at all these humanoid robots that are doing these tricks and climbing over obstacles and so on. There isn't enough time to train those robots in the real world. So NVIDIA has done a lot here to develop the software infrastructure. So folks are able to do all the training in simulation and then do the final tweaks in the real world. So the sim to real methodology, I think, is paying off huge dividends there. I think that still a fair amount of work needs to be done in translating what a robot sees, perceives, and then turning that into a knowledge model. So as a tangent, I wanted to say that, we talk about these things being large language models, but then what we use them for are knowledge models, right? So implicit in the language connectivity that these systems see when they're being trained, they're implicitly finding the knowledge, right? As opposed to us explicitly telling the system facts and then it memorizing those facts. So it's previously we were trying to build expert systems where we would train the system on facts and then we could query those facts. And now we're just tossing a bunch of language at it and then hoping that the facts are correct. So I think a fair amount of work has to be done there between a robot inferring something, or your physical system, robotics inferring something, and then translating that into a accurate representation with no hallucinations and no data loss, so that you can actually make good decisions. So that's one piece that has to get addressed. And as long as LLMs are going to continue to hallucinate, it's going to be very challenging to put that into a robot and have a robot do something, right? Because you don't want the robot to treat a baby in the same way that it's going to plate, right? So they can't really, you have to be sure that what the robot is seeing is the right thing. So there's a fair amount of work that has to get done to get that confidence level up, and for the robot to actually understand that I don't have enough context here to make a decision. I'm going to pause. I'm going to ask for more input, which also is going back to your question previously about what are some things we need to do with LLMs as the next step. So I think this thing of the LLM being smart enough to ask when it doesn't have enough context is going to be useful. So we need that to be put in place. And then we need a whole bunch of software related to safety around robotic systems, because we've seen videos of robots go crazy and they can cause some serious damage. And right now, I don't think the humanoids and the software that goes into them is safe enough to be around humans, certainly in a consumer environment, but even in warehouses. I do think there's plenty of opportunity for humanoid robots or four-legged robots outdoors. And I think that RISE Robotics will get to play in that space because motors don't really scale to that level. And so you're going to need linear actuators like the ones we build. But indoors, I think there's a fair amount of work needed to be done to get to that level of confidence. And even though we've solved for legged motion, I think there's still a huge amount of work that has to be done in manipulation. Because when you think about what we can do with our fingers and how we can close our eyes and touch something and understand what it is, I don't think that we're quite there with robots. And yes, we've seen certain corner cases. I think there was a figure robot, or that was sorting packages. I forget which company had that. And I look at that system, I'm like, wow, you could just digitize that, right? You could take this package and basically put it on a table that has 30 air jets, and you could just turn that package any way you wanted. You don't really need manipulation to do that. And you could do that much faster with what is quote unquote would be a digital system, right? Where you're just manipulating it digitally in space. So I think that manipulation has to get to be a lot better before it can start competing with other fixed industrial solutions. I think that's probably the other frontier that has to get solved.
Fair enough. And you kind of alluded to something I just saw on social media the other day. China even had a problem with that. They were doing a parade of their robots, and one of their robots actually kicked a kid in the stomach fairly hard. So safety is a major concern, and nobody has really solved that yet. Do you think that BCI and brain-computer interfaces will help with that translation data?
That's interesting. That's a fantastic question. I certainly think that brain-computer interfaces can help with training, right? And in fact, you don't even need the brain-computer interface to be connected to a real robot. As we discussed before, it could just be connected to the sim of a robot, and you could be doing manipulation of things in virtual space and then use that to train a model that can then be locally or even remotely control a robot system. So I think there's going to be some value there. I think it's going to make the process of training a robot more efficient. But I think we still have to solve the corner case of what happens when the robot doesn't understand something. Is it going to hallucinate? Because in those instances, the system is very unsafe.
Yeah, the safety problem is something I never really thought of, because again, you get indoctrinated by all of these articles and you just like, oh, this is amazing. But I didn't realize that we weren't that well. But you did add a good point, because I built an old car with my grandfather. It was my first vehicle, an '83 El Camino. But I know for a fact that the being able to get your hands into certain spots and be able to understand what to touch and what not to touch, and how to pull the ratchet at the right moment, or even just like sanding wise, having the understanding that you need to sometimes switch your hand position or not apply so much pressure. I never really thought about that level of data before. Yeah, I'm very excited. I have a question, and I don't know if you're going to be able to answer this, but I've been throwing around this theory that we're going to end up with a world of superheroes and supervillains. Do you see that as an actual reality?
Unfortunately, yes, because I think that there are two things that are happening. So first is, folks that are concerned about their health and their lifespan are often willing to do a lot of things, especially if they have a lot of money. They're willing to do a lot of things to extend their lifespan. And so I can see the next stage being human augmentation, where folks are, we already are replacing joints. I can see if there was a solution to Alzheimer's that involved putting a LLM in your brain, I'm sure many people will pick it and make it happen just so that they could continue to be independent and capable, right? So I can see all of that starting to come in place. And then now, the same thing on the athletic side, right? I see what athletes are willing to do to get an edge. You only have to look to Lance Armstrong to see what he was willing to go through, blood transfusions and so on and so forth, and risk so much to be the best. And there are groups that are calling for there to be categories of sports where athletes are allowed to take performance enhancing drugs. And that's like the first step. And the next thing it'll be, okay, well, maybe they can augment themselves with other things, right? And so I can see how this trend continues. And I do think that eventually there is going to be that situation. And I don't know how we would handle it from a law enforcement perspective. It's not something I'm looking forward to, honestly, because it really interferes with one of the foundations of the United States, which is everyone's created equal as a starting point. And if you end up having people with a lot of money be able to start at a far higher level than anyone else and be more capable, I don't know how it ends up staying a fair world that's based on meritocracy, which is something that I'm inspired by. One of the reasons why I love coming to the United States and being an immigrant here.
It's one of the things Canada has lost. It's one of the things I fight against a lot. It's one of the reasons I left the government, was because I was absolutely disgusted at the level of just complacency especially when you get into the higher stages of the career, it's like they just cover their ass. They don't want to actually like do the work and try and do better. They just are good with how it goes, and it's straightforward. That caused a lot of mental health on my part, and I had to leave because of it. And I worry that we're going to get too complacent with all these models. Do you see AI taking over for our teaching structure to help that?
I think in general, what I see happening over the next 5 to 10 years is that AI is used as augmentation. I don't necessarily see it as replacing. I do think that I do think that the opportunities to tailor education using AI could be huge, because in a lot of developed countries, I see focus on education being to make sure that there's a floor, that we're not leaving any child behind, right? But there doesn't seem to be as much emphasis on finding kids that have particular strengths and then really helping them elevate their game. And so that's where I think, especially when it comes to gifted programs, that AI can help. It can certainly help on helping students that have challenges with a particular topic to get support, because we all learn differently. For example, I'm a very visual thinker. If I am talking to somebody about a problem, I need to be in front of a whiteboard. If someone has a long list of things they want to tell me, I want them to start with the bottom line first, because otherwise I won't be able to keep track of all the facts that they're throwing my way, which also goes with being a visual thinker. So I start with the top and then kind of work my way through the details. But then there are other people who learn through listening, and then there are other people who learn through movement. And so you have to take what may be an abstract problem and convert it into something that requires them to move to learn and internalize what's happening. And I think that AI can allow us to do that with fewer resources. But ultimately, I think it should be augmented by an educator who's taking a look at the output and sort of coming back and saying, we need to make these adjustments, or this system really isn't working for the child. Because I don't think that we can rely on AI to just do all of that. We can see it as a tool. I don't necessarily see it as human replacement tech.
I appreciate that thought, because I see way too many people using it as replacement and thinking it can do everything and then trusting it. I don't trust any of my outputs. I have to run it through several different models before I'm like, oh, okay, I'm sort of confident with this. And if it's in a field that I don't know, I won't post it, because I'm like, I'm sorry, it's just too much for me.
That's interesting.
I think
even
that's kind.
even
Yeah,
as
go
the
ahead.
CEO of a company, there are a lot of decisions that kind of fall on me to make. And I'm usually making sure that I talk to at least one other person about the call, just to make sure that I haven't missed anything. Sometimes it's a direct report, sometimes it's a founder of the company, sometimes it's a direct report that knows more about the problem than I do. And sometimes it's a board member that has more perspective than I do. And so you get on a phone and you say, hey, this is what I'm thinking. What do you see this? And so on and so forth. And so if I'm reviewing my own work and having it reviewed by somebody before acting on it, because the consequences are huge, why would I trust AI when, right? I mean, how can I just blindly look at, I have to check everything. And so I agree with you 100%. If folks that are blindly trusting the output of these systems, or thinking that we can take an LLM and put them into a robot and put the robot into a home, they're bonkers.
No, I appreciate the sentiment, and this is one of the reasons I like to talk to people like you, because I get to bounce my ideas and my thoughts off of you guys, and then you guys, being the experts, actually like help me develop my understanding so that I can work better and do these things. It's kind of selfish of me, but I really do enjoy being able to speak directly to experts like yourself. So I'm out of questions, but I do want to just ask one final question on the RISE Robotics things. Where do you see your company in 5 years?
Yeah, so we have 3 business areas. We have the work that we're doing for the Department of War, Department of Defense. We're building them these munitions handling units. I expect to win a production contract, which would be roughly 300 million plus, to go build these systems. And we're going to really impact the lives of the folks that are loading these planes. They have been inhaling diesel smoke. They've been yelling over loud diesel engines. They're working with equipment that's leaking. They're spending time cleaning up hydraulic oil leaks when they really should be focused on the mission. So very excited about that. We've also been able to land our first Army contract, and we found a champion in the Navy. So I think that our business is going to expand beyond the Air Force. So over the next 5 years, I expect to have 2 other customers in the Department of War. And then in our liftgate business, I expect us to be deployed across several fleets. So we'll be doing another pilot this year. We're talking to a very large leasing company. So they buy thousands of liftgates a year. We're really excited about the prospect of getting that into market and through them reaching hundreds of customers. So looking at partnerships like that. And then on our cylinder business, I expect us to be fully deployed in the oil and gas space. I expect us to be making inroads into marine, and I expect us to be making inroads into Europe. So very excited about those opportunities. While we're doing all of that, I'm looking at kind of the overall financial model and keep my fingers crossed here. Our goal is to be a unicorn in 5 years, so get to 100 million revenues. That's going to require a lot of execution. There's a fair amount of risk there, but that is the ultimate financial vision for the company.
Honestly, aside from outside intervention and some people just not understanding, your technology is revolutionary. I highly suggest any of the audience look up who you are at RISE Robotics and start looking at how they can leverage them in other technologies, because I really do see this as a world-changing potential. So who are you? Where can people find you? And anything that you'd like to leave the audience?
Sure. Yeah, they can find us at riserobotics.com. We have a form there where they can fill out information if they think that we should get in touch with them as customers. If someone wants to connect on me on LinkedIn, that's welcome. And also, if folks think that this technology is going to be something that's transformative and they want to buy a small lottery ticket, they can invest in the company for as little as $250. There's an invest button on our website that they can click on and look at our presentation on why we think that we're a compelling business. And then on the same campaign page, there are a couple of other investors who've written investment memos, which describe both the upside and the risk. So these are third-party assessments, and they can read those and determine if investing in the company makes sense for them.
Very fair. And I'll make sure everything's down in the description down below. To everybody out there, thank you for listening. Please like, comment, subscribe, and all the bullshit I'm supposed to tell you. Thank you for listening. And please reach out if you need anything. To everybody out there, stay weird.